Electrical engineering is a broad field, but some fundamental concepts are essential for understanding how electrical systems work. Firstly, let's define what a circuit is. An electrical circuit is a closed loop that allows electrical current to flow. It typically consists of a voltage source, conductors such as wires, and one or more electrical components. A simple circuit might include a battery, some wires, and a resistor. Secondly, voltage, current, and resistance are three interconnected concepts that govern the behavior of electrical circuits. Voltage, measured in volts, is the electrical potential difference between 2 points in a circuit. It's the driving force that pushes electrons through the circuit. You can think of voltage as the pressure in a water pipe. Current, measured in amps, is the rate of flow of electrical charge. It's the number of electrons passing a given point in a circuit per unit of time. In our water pipe analogy, current would be the amount of water flowing through the pipe. Resistance, measured in ohms, is the opposition to the flow of current. It's a property of the materials and components in the circuit that impedes the movement of electrons. In our water pipe analogy, resistance would be the narrowing of the pipe, making it harder for water to flow. Thirdly, Ohm's law describes the relationship between voltage, current, and resistance. It states that voltage equals current times resistance, or voltage equals current asterisk resistance. This law is fundamental to analyzing and designing electrical circuits. For example, if a circuit has a 12-volt voltage source and a 6-ohm resistor, the current flowing through the circuit would be 2 amps, because 12 volts equals 2 amps asterisk 6 ohms. Rearranging Ohm's law, we can find current as voltage divided by resistance, or current equals voltage/resistance. We can also find resistance as voltage divided by current, or resistance equals voltage/current. Fourthly, electrical power is the rate at which electrical energy is transferred in a circuit. It is measured in watts. Power can be calculated using the formula power equals voltage asterisk current. For example, if a circuit has a 12-volt voltage source and a current of 2 amps, the power dissipated in the circuit would be 24 watts, because 12 volts asterisk 2 amps equals 24 watts. We can also express power in terms of resistance. Since voltage equals current asterisk resistance, we can substitute this into the power formula to get power equals current asterisk resistance asterisk current, or power equals current squared asterisk resistance. Similarly, since current equals voltage/resistance, we can substitute this into the power formula to get power equals voltage asterisk voltage/resistance, or power equals voltage squared/resistance. Fifthly, resistors are components that provide resistance to the flow of current. They are used to control the current and voltage levels in a circuit. Resistors come in various values, measured in ohms, and various power ratings, measured in watts. The power rating of a resistor indicates the maximum power it can dissipate without being damaged. Common types of resistors include carbon film resistors, metal film resistors, and wire wound resistors. The value of a resistor is typically indicated by a color code consisting of 4 or 5 bands. Each color corresponds to a digit, and the bands are read from left to right. Sixthly, capacitors are components that store electrical energy in an electric field. They consist of 2 conductive plates separated by an insulating material called a dielectric. Capacitors are used to filter signals with voltage fluctuations and store energy. Capacitance is measured in farads. Common types of capacitors include ceramic capacitors, electrolytic capacitors, and film capacitors. Seventhly, inductors are components that store electrical energy in a magnetic field. They consist of a coil of wire. Inductors are used to filter signals, store energy, and create magnetic fields. Inductance is measured in henries. Common types of inductors include air core inductors, iron core inductors, and ferrite core inductors. Eighthly, diodes are semiconductor devices that allow current to flow in only one direction. They are used to rectify alternating current, protect circuits from overvoltage, and switch signals. Diodes are characterized by their forward voltage drop and reverse breakdown voltage. Common types of diodes include silicon diodes, germanium diodes, and light-emitting diodes, or LED. Ninthly, transistors are semiconductor devices that can amplify or switch electronic signals and electrical power. They are the fundamental building blocks of modern electronic devices. Transistors come in two main types: bipolar junction transistors, or BJT, and field effect transistors, or FET. BJT are current-controlled devices, while FET are voltage-controlled devices. Tenthly, integrated circuits, or IC, are complex circuits that are fabricated on a single silicon chip. They contain millions or even billions of transistors, resistors, capacitors, and other components. Integrated circuits are used in a wide variety of applications, including computers, smartphones, and consumer electronics. Understanding these fundamental concepts is crucial for analyzing, designing, and troubleshooting electrical circuits and systems. These principles are the foundation upon which more advanced topics in electrical engineering are built. As you delve deeper into the field, you will encounter more complex circuits and systems, but the basic principles will remain the same. For example, when working with alternating current or AC circuits, you'll still use voltage, current, and resistance, but you'll also need to consider impedance, which is the AC equivalent of resistance. Impedance takes into account the effects of capacitors and inductors on the flow of current in an AC circuit. Similarly, when working with digital circuits, you'll be dealing with logic gates, flip-flops, and other digital components, but these components are all built using transistors, resistors, and other basic circuit elements. So, a strong understanding of the fundamentals will serve you well as you continue your studies in electrical engineering. One key skill to develop is the ability to read and interpret circuit diagrams. Circuit diagrams use symbols to represent different components and connections in a circuit. By understanding these symbols, you can trace the flow of current through a circuit, identify the function of each component, and analyze the overall behavior of the circuit. Another important skill is the ability to use measuring instruments such as multimeters and oscilloscopes. A multimeter can be used to measure voltage, current, and resistance. An oscilloscope can be used to visualize the voltage waveform in a circuit. These instruments are essential for troubleshooting and verifying the performance of electrical circuits. When working with electrical circuits, it is always important to prioritize safety. Electrical shock can be dangerous or even fatal. Always disconnect power before working on a circuit, and use appropriate safety equipment such as insulated tools and gloves. Be aware of the voltage levels in the circuit, and take precautions to avoid contact with live wires or components. It is also important to follow the National Electrical Code, or NEC, which sets standards for the safe installation and operation of electrical systems. The NEC provides guidelines for wiring, grounding, overcurrent protection, and other safety-related aspects of electrical systems. By following these guidelines, you can ensure that electrical systems are installed and operated safely. Consider a practical example to solidify the understanding. Imagine you are designing a simple lighting circuit for a room. You want to use an LED light bulb that requires 12 volts and draws 0.5 amps. You have a 120 volt AC power source available. To step down the voltage from 120 volts AC to 12 volts DC, you will need a transformer and a rectifier circuit. The transformer will reduce the AC voltage, and the rectifier circuit will convert the AC voltage to DC voltage. You will also need a resistor to limit the current flowing through the LED. To calculate the value of the resistor, you can use Ohm's law. The voltage drop across the resistor should be equal to the difference between the output voltage of the rectifier circuit, which would be 12 volts DC, and the voltage required by the LED, which is also 12 volts, so technically we could say 0 volts. Therefore, the voltage drop across the resistor is 0 volts. The current flowing through the resistor should be equal to the current drawn by the LED, which is 0.5 amps. Therefore, the resistance value should be R equals voltage slash current equals 0 volts slash 0.5 amps equals 0 ohms. In this case, no resistor is needed because the LED is rated for the exact output voltage of the supply. However, In practice, it is wise to include a small value resistor to account for any variation in LED voltage or the power supply's voltage. If you were designing a high-power circuit, you would need to consider the power ratings of the components. The power dissipated by the resistor can be calculated using the formula power equals voltage asterisk current. In this case, the power dissipated by the resistor would be power equals 0 volts asterisk 0.5 amps equals 0 watts. Therefore, you would need to choose a resistor with a power rating of at least 0 watts. In practice, it is always best to choose a resistor with a higher power rating to provide a safety margin. By carefully considering the voltage, current, resistance, and power requirements of each component, you can design a safe and reliable lighting circuit. Remember to always follow the National Electrical Code or NEC guidelines when working with electrical systems, and to take appropriate safety precautions to avoid electrical shock. With a solid understanding of these fundamental concepts, you'll be well equipped to tackle more advanced topics in electrical engineering. Keep practicing, experimenting, and building circuits to reinforce your knowledge and develop your skills.